All right, so we're on section 3.8, and today we're looking at inverse of functions. You guys have done this before. I don't think it's very hard. And if you just follow along with a few examples that we have, you'll be fine. Okay. So first of all, we want to look at if you switch the coordinates of a function, or of ordered pairs in a function, the resulting set of ordered pairs is called the inverse of the function. So really all we're doing is taking the x's, making them y's, and vice versa. Okay? So for our first example, we're looking at, we have all these ordered pairs. Can you guess what the new function would be if we inverted it? The other way around. -5, -3. Okay, what would the next one be? 0, -2. Good. 3, -1. 4, 0. 3, 1. 0, 2. And last is -5, 3. So see, we're not doing anything to the numbers but switching the order in which you list them in the ordered pair. Okay? If the original function is described by an equation, then what we're going to do is actually switch the x and y in the equation. Okay? So I'm going to give you an example of that. So this first one, we have the equation of y equals -x squared plus 4. So what you're going to do is switch the y and the x. So this becomes x equals -y squared plus 4. Okay? We don't want to leave it in -y squared plus 4. We need to solve for y. Okay, so how do I get y squared by itself? Yep, subtract 4 from each side, so we have x minus 4 equals -y squared. Yeah, we will in just a minute, but what do I do with this negative? Yep, so it'll be -x plus 4 equals y squared. All right, so now we want to take the square root of this. I'm just going to move this up here because I'm running out of room. So y equals the square root of -x plus 4. Huh? They're y's. Sorry. No, we're going to leave it like this. Yeah, this is how it stays. Okay? Okay, so first of all, I'm going to want to put a graph into this. So I'm going to insert a document graph. And I'm going to actually graph the first one that we had, which was -x squared plus 4. So there's our first equation. Our second equation is going to be a square root. So I'm going to add that in here. So this is how it looks like when I put it into the equation. Oops, sorry. This will be square root of -x plus 4. And notice what I have.
Oh, wait, why? I thought it was x plus 4. How's it -x minus 4?
Well, when we took the negative around, so before you're asking why isn't it x -x plus minus 4? Okay, so come back here. Notice that we have a negative here. And so what we did was we took that negative and gave, times each one by negative. So that becomes -x plus 4. Okay, one thing I want to point out is that because of the nature of this, really the full equation is this one right here. This is the actual equation without taking the square root. So if I were to draw this again, remember on the cast it had something like this. And then the new equation, if I don't take the square root, is going to be something of this nature. Correct? All right. It's almost like a heart. But the cast automatically chops off the bottom because it makes it into a function. Okay? But in reality, if I don't take the square root, it is not a function. But notice how it is reflected over this line. This is the y equals x line. And basically this blue, notice, gets, if you were to fold the graph on that line, that blue would match up to that red if I were to fold it. Okay? So what you're doing when you're inverting a function is really you're folding along the diagonal. Okay? And in this case, this is not a function if we don't take the square root. Remember, the definition of a function is if I take a vertical line and draw it through this, it comes in two spots, right here and here. That means it's not a function, right? Okay? So the main gist that I want you guys to see is that it's basically you're folding the function over the diagonal line of y equals x to make your inverted function. Okay? So that goes right here. Images each other over y equals x. Okay. Next, I want to talk about this function right here. What is the parent function of this one? Yeah, y equals x squared. And what does that make usually when you graph it? It's a parabola, right? Okay. Based on this, how does the parabola change from the parent function? Yep. It's a stretch, a vertical stretch of what? What's the vertical stretch of? No? It's right here. It's 2. Okay? Okay, what is the translation of it? Left 5, down 1. Good. Okay? So here it says we want to give the equation for the inverse of this function. So what's the first thing I'm going to do? What do I have to change? The x and the y. Right. So let's rewrite this. This is going to be x equals 2 times y plus 5 squared plus 1. Okay, so we're doing the inverse right now. Oh, yeah, sorry. It's a -1. It's my fault. Thank you. All right. So now we need to solve for y. Okay. So first, we're going to add 1 to each side. We have x plus 1 equals 2 times y plus 5 squared. Then we'll divide both sides by 2. So then we have x plus 1 divided by 2 equals y plus 5 squared. Okay, now I'm going to move to the next line over here. So then we have the square root of x plus 1 over 2 equals y plus 5. And then we subtract 5 from both sides. So we have x plus 1 over 2 minus 5. That's outside the square root, you guys.
Could you flip it around and use y?
What do you mean?
Like, put the y first and then y equals the square root of x plus 1 over 2 minus 5.
Oh, no, you have to square root before you subtract the 5.
No, like, I mean, like, put the
y
y
right,
like, on the right.
it,
Yeah.
and you put y
Like, the
equals.
y.
Yes, yes. Oh,
Okay,
yes,
okay.
yes,
Okay.
yes, yes. So what you're saying is if I wrote y equals
Yeah.
this first. Yes,
Yeah.
that means the same thing. Yep.
Wait, why wouldn't we?
Okay, so let's go to a new document. And let's graph this original. So we have 2x plus 5 squared minus 1. Oopsie. Okay, so here we are. That's our original graph. Can you guys make a prediction of where the new graph will be?
Should be facing like that way.
Correct. It's going to be facing towards the right. And where's the new vertex? Huh? It'll be -5, but it's going to be, remember the y and the x changes spots. So here's our vertex right here. It's at -5, -1. So where's our new vertex going to be? -1, -5. We just talked about how this is the vertex of -5, -1, and you know that the new vertex is going to be -1, -5. So down here.
Wait, why are they changing? Why are they flipping?
So Monet, you need to watch this in a few minutes, okay?
Okay.
All right. So now let's put in the new equation to see what actually happens. I'm going to do square root. Okay, and I'm going to say parenthesis x plus 1 divided by 2. And then I'm going to subtract 5 from it. And notice what happens to it. It only shows half of it, right? Okay? So if I were to actually put in the equation y equals x, is that the mirror image of it? Yep, it is. Okay? So the new vertex changes, just switching the y and the x to it, so you're going from here to here. And it's a new parabola, and it's like lying on its side. So if you're going to go and write these yourself without actually changing the equation, basically you would just take the same parabola, move it to its new location by switching the x and y for the vertex, and flip it on its side. This is still not a function. If this was actually drawn completely, because it would be a full parabola, it would not be a function.
So it's not a function.
How are you getting two of the things? Like, how many at one?
Notice that we have, what's the parent function of this, first of all?
1 over x.
Yeah, 1 over x, which is an inverse function, correct?
Yeah.
Okay, so we need to actually go through to find the inverse of this. We're changing the x and the y.
Okay.
Okay, so now this f of x becomes x, and then the x becomes a y.
Why?
All right, so we want to actually go and solve for y now at this point.
Oh, yeah.
Okay, so this becomes x minus 4 equals 1 over y minus 3. Well, we're going to multiply by the entire thing of y minus 3, okay? So if I multiply both sides by y minus 3, these two totally cancel out. So I have y minus 3 and x minus 4 equals 1. Now, what do I do? Just
You put it.
divide by x minus 4. The whole thing. So now we have y minus 3 equals 1 over x minus 4. Then you add 3. Good.
So then you have y equals 1x minus 4 plus 3.
We're going to use the cast to record what we just did. So I'm going to open a new document, insert a graph. So first of all, let's graph the original function. So this is going to be 1 divided by
X minus 3
x minus 3
plus 3.
plus 4. Okay? So here we are. There's the first function.
Okay, and then do you press tab? And then do...
We're going to go to menu again and put in a graph function. Okay, so then we're going to do the same thing, except this time it's going to be 1 divided by x minus 4.
Plus 3.
Oops,
What you didn't do plus
I know, I got to fix that. 1 minus, okay, plus 3. There we go. All right, can you guys tell by looking at this, does it look like an inverse function?
Yeah.
Okay, so one thing I want to do is actually draw the line of y equals x on here so that we can actually see it. So I'm going to add that in. Yep, so notice that if I took the first one and folded it down, the tan one folded down across this blue line becomes the brown.
Yeah. So
Okay.
that's because it's symmetric.
Yeah, basically it's symmetric around the blue line, right? That's the y equals x. So an inverse function is the original function. I actually folded on the diagonal of y equals x, and then you see the image of it, the mirror image on it of the other side. Can you see that? Okay, so since we could fold it over and we actually saw the function, it does become a function in its inverse form, okay? So looking down below, there's a couple little things I want to add to what we're talking about here today. When the inverse of a function is a function, it is denoted by the symbol of f of negative 1. And that you read it as f inverse. Therefore, the inverse in this example can be written like this. F of negative 1 x equals 1 over x minus 4 plus 3. Okay? So the inverse of the f of x can be written this way. Okay, there's a word of caution that I want to tell you. Okay, so please write this down. F of negative 1 is not 1 over f. Please, if you don't remember anything today, remember this. Okay, because normally when we're talking about a number to the negative 1, it is this, but we're talking about a function, so it's a little different. Okay? So that is not the case. Okay. All right, so now, here is the theorem of inverses of functions. It says, given any two functions, f and g are inverse functions if and only if f of g of x equals x. For all x in the domain. So what it's saying is that I can check to see if two functions are inverses of each other by actually doing a composite function of it. And if the output is x, then it's a function. Okay? So, what I'm going to do now is take this last example and do that. I'm going to do it on this next page because there's not enough room. So, f of x was 2x minus 4 over x plus 1. And g of x is x minus 1 over 2x plus 4. So the first thing we're going to want to do is actually find f of g of x. We learned this yesterday. Remember, that's the same thing as saying f of g of x this way.
Wait, is that
So weird.
Yeah, that's the little dot. Open dot. So, I need to actually see if f of x minus 1, oopsie, x minus 1 over 2x plus 4, if that equals x. I need to insert that in. So this is going to take a little bit of work, some manipulation. So here we go. 2 times x minus 1 over 2x plus 4 minus 4. See how I replace the x with this?
Couldn't you just, wait, why do you have to do f of g of x? Couldn't you just like take the inverse of f of x and then just see?
You could do it that way too. You could. Actually see if they equal each other. The question was, can I take the inverse of f and see if that equals what g is?
Yeah.
And you could do it that way too. But this is also another way. I'm just trying to show you how to use this theorem. Okay? So then we're going to put, because this is just an x, I'm going to put x minus 1 over 2x plus 4 plus 1.
Wait. Don't you have to put that little number in there? Oh, okay. Never mind.
All right. So this becomes, if I take that 2 and distribute it, it's going to be 2x minus 2 over 2x plus 4. Now, one thing you got to know about fractions is I have to have a common denominator, do I not? Yeah. So this will be minus 4 times 2x plus 4 over 2x plus 4. Yeah, this is going to be a bit of work. Okay, so the
Wait,
bottom,
is that just the top?
that was
Or
just
are
the
you
top.
kidding me?
The bottom one is x minus 1 over 2x plus 4 plus
This is just like way overcomplicated.
2x plus 4 over 2x plus 4.
How do you have like a fraction minus a fraction over another fraction minus?
Oh, just get ready because we got more of this coming in our
Let's
test.
just not. Can we just quit?
No, we're going to keep
You
going.
could just pass this all over x minus 1 plus
So
2.
now at this point, I am going to,
Wait.
I'm gonna get rid of this and
Can't
this.
you just take it off of the top? Can't you just divide 2x plus 4?
No, you can't. You can't do that.
Are you kidding me?
No. All right, so 2x minus 8x is what? Negative 6x. Negative 2 minus 16 is negative 18. Okay? What is x plus 2x? 3x. Good. And what is negative 1 plus 4?
3.
Mm-hmm.
And then you divide that so then you get 2x.
Nope, you can't divide that.
Why can't you divide that?
You can take out a 3 out of all of it.
Right.
So let's divide everything by 3. We have negative 2x
Why are we
minus 6 over x plus 1. Nope, they're not. They have to have the exact same polynomial to be able to cross them out. So this is my answer right here. Nope, that's as simplified as you can go.
Why couldn't they just tell us this in the beginning?